Sorry, I don't have your picture.
Oh yeah, sorry. My picture, by the way, is, you will see, you're starting to see the recording from this morning to now. You will see that, of course, I need a haircut, no? But more than we move through the day, I'm starting to be more stressed, more than my hair is going to go up, okay? So you can compare the different, so that's showing my picture. Yeah, you will have a kind of you can do an experiment. You can place my, okay. I'm going to call this function the quarantine function. Now, after 4 months, how someone look like. Okay. Of course, it's an excuse. Everyone knows that. Okay, so I think that I'm recording this. I think. Yeah, recording has started. You can see my screen. Perfect. So let's go and try to resolve the exercise. Keep in mind that for all of you, know that you find problems resolving the exercise. This is a skill, okay? And take time to develop this skill, okay? And because it takes time to develop this skill, don't worry. You eventually you will do it. But as I said, it's kind of a develop a new language, no? You need to develop a new language to communicate with the computer. So, as I said, give you time. The most common error that you will find is that you are not using the right path to the file. So let's go and try to resolve this that way. Okay. So so this is my screen. So my screen, I was using top to see all the processes, as I explained to you before. So there are some people, well, mostly myself. I can see Lawrence running Bash and Tmux. Okay. So please don't hack the server. Okay, for all of you that you know about doing complicated things, don't hack the server. Give me a lot of problems. Okay. So let me go to these references. That is where I have all these files. Can you see my screen with the terminal?
Yes.
Yeah.
Yes. Yes.
Yes.
Okay, good. So so the first file that we need is this one. Okay. So, and the first exercise is counting sequence in this FASTA file. Okay. So we want to do, using a simple Linux command, count the number of FASTA sequence into a file. So if we go to the file, and of course you don't need to do that, you only need to run the command, but I will explain the process to you. So if you use less, and with less you can see what is inside the file, you will see that if I open the file has the following structure, because this is a FASTA file. You have a greater than, then you have the ID, and you have one of these lines per sequence. And then you have a multi-line sequence, okay? So if I say grep greater than, and then the name of the file, and okay, the thing that grep is going to go do is going to go to this file, and it's going to try to find this character, and then once find the character, is going to print the character. Why I'm using single quotes is because this character that you can see here is a special character. So if I use without quotes, the thing that means is redirect the output of whatever you are running before into this file. Okay? So remember that you need to use single quotes, for example, just to use this as a character. So if I do this, without -c, it's going to go line by line, and it's going to print the line. If I use this with the option -c, it's going to tell me that I have 7 sequences. Some caveat. When I'm not writing the whole file, okay? So the thing I'm doing is I'm typing ART and then I type in tab, and the tab is completing the file for me. So you don't need to type everything. Okay. Perfect. Questions about this exercise? So please ask questions, as I said. So if you, for example, let's put some common errors, okay? Imagine that I'm trying to run this in the wrong directory. So I'm going one directory up. And if I try to run this in the wrong directory, it tells me no such file or directory because the file is not there. Why? Because I'm using the wrong relative path. If I use the right relative path, will work again. Or if I'm using the absolute path, no, this is not the absolute path. Yeah, sorry, I forget this RNASeq. Okay. 90% of the times that this doesn't work is because you are not using the right path to the file. So that is the first possible error. Second error, you see this file, okay? So here the file is 116 megs. But imagine that for some reason I ran this wrong, okay? Imagine that for some reason I forget the quotes. The thing that I'm going to do is I'm going to overwrite the file. So if I do this, it's telling me, oh, you did an error. You are not working this properly. But now, if I check the file, I already delete the file. So if I try to do this exercise again, it's going to fail because I already overwrite the file. Okay? Because this was interpreting, run this and overwrite this file with this output. So let me copy the file again. Okay. Questions about this part of the exercise? Okay. If you don't have questions, let me.
I have a question.
Yeah.
About the differences between the single quote and the double quote. I did the exercise with double quote and I get 7.
Yeah.
So it's the same?
It's the same. In this case, double quotes work too.
Okay. Okay.
It's a special character. Other special character may not, but in this case, double quotes with greater than works.
Okay, thank you.
Okay, so let's go to exercise 2. So we are going to count nucleotide in FASTA files. Again, we want to use a simple Linux command. Again, we are going to use this as an input. And the recommended command is the same one that before, but we are going to pipe the output. Okay. So, in this case, if I grep -v means instead print the line that you are trying to look for, is ignore the line that you are trying to look for. So it means that in a FASTA file, and I'm going to use the double quotes just to also exemplify that double quotes can be used too. So if I do this, the thing that is going to happen is that grep is going to go to the file and it's going to ignore delivery all the lines that contains this greater than. So if I do this, as you can see, my computer is starting to be a computer from Matrix, just printing the Arabidopsis genome. Okay. If you need to stop this, remember, Control-C. Okay, so what just happened? The thing is, grep went to the file and starting to ignore just this greater than symbol. If I pipe this into a different command, and this is this pipe symbol, I will pipe this output that you see in the screen into a new command. This new command could be something as simple as head. Okay, so I'm printing only the first 10 lines. Or I can use a command to count characters. So this command to count characters is WC. So if I say WC-M, I'm telling this command take the output that is going to receive, count how many characters do I have. If I do this, it's telling me that I have 121,182,535 characters. If in a FASTA file you ignore the description lines, the ID lines, you only will have the nucleotides. So this number will be equivalent to the number of nucleotides of your FASTA file. In other words, the Arabidopsis genome, just look into this file, has a size of 121 megabases. If you want, WC is a very useful command. So you want to look how different options do you have. You can type man space WC, and you will open the manual. No, so you can count with these bytes. You use -C. You can count characters. You use -M, or you can count lines. You use -L. Questions about this exercise and the solution of this exercise?
Yeah, I have two questions. The first one is the command -V kind of the contrary, the opposite of -C?
-V, the opposite of...
No, it's not the opposite. It's, I mean, why didn't we use the -V before when we were counting?
Because before we were counting an event, and now we are trying to ignore the same event.
Okay, so it is kind of the opposite. Okay.
Well, -V is the opposite of just grep. So if you just run grep without not argument, will be the opposite of grep -V.
Okay, I see.
Yeah, -C, the only thing that -C does is count. So instead print, the output is going to count how many lines do you have. So -V is not exactly that. Of course, you can combine -V with -C. So you want to count how many lines do you have. How many lines do you have? No, it's telling me that all these sequences I have has indeed 151, well, almost 1.5 million of lines. This will be exactly equivalent to this, or should be equivalent to this. So -C is not exactly the opposite. -V, so that will be just, -V is the opposite of just the regular behavior of grep.
Okay, I see. Thanks.
Yeah. Any other question? Okay, if you don't, let me go to the next exercise. 3 will be count annotations in FASTA files. So for this example, the thing that I'm asking you is to first to download a file using wget, and second, well, you need to unzip it and then count the kinases. So let's go to the first part. Let's first download the file. So I have already the file here, so I'm going to remove it. So I have removed the file, and then I'm going to use this wget. Okay, so I just copy and paste wget, and of course it's failing because I copied the file in 2 parts. Okay, so 1 moment. Be careful when you are copying and paste things from a PDF file, because this is something that can happen at some moment. Okay, so I'm downloading the file. So you can see the file here now. I'm going to unzip it. So you see the file, unzip it now. And now let's take a look first of the FASTA file, just to the identifier line. So if I do this, and let me print only the first 10, this is how looks the identifier. So you see, this is the abscess identifier, and then the description, and then something else. So the idea here is that if we pipe this into another grep, and we say, for example, kinase, okay, it will go and look for these lines and print kinase. That would be an example. Then we can pipe this to wc-l, and we'll count how many identifications have the word kinase. So in this case, I have 2,758. Of course, we can elaborate this a little bit more, and even one possible option that you could do it is because kinase is not going to appear. Well, the question is, can the word kinase be a protein? Do we have some protein letters that could be? Of course, we have E-S-N-A-N. I think so. I don't think so. So indeed, should not be the problem. So one possible option, that would be even a simpler way to do the exercise, will be to say, count how many kinase lines do I have? Yeah, the result is the same. Question about this one.
Yeah, about the syntax. Why, when we pipe the second grep command, we do not use the quotes?
Well, in this case, it's because kinase is a word that is made with regular characters. You don't have any special character.
Okay.
So I was just lazy. So, but yeah, in this case, it will be the same to put quotes or don't put it there.
Okay, thank you.
But if we don't put the quotes, in the other way you wrote grep -c kinase without the quotes, we don't find anything?
No, I think that we should find the same thing. Yeah. When you don't have special characters, you don't need to put the quotes if you want. As I said, I like to put them as yeah. Okay. So let's go to the exercise number 4. Counting elements in a DFF files. DFF files has this oh yeah, I think that's I may make the mistake. Maybe not. Oh, okay. So DFF files are files that contains 9 columns. So if we take a look of this DFF file, this is how it looks a DFF file. You have comments, and then you have 9 columns. Some of them can be very long lines, but basically you can find the 9 columns here. No? So you have sequence ID, source of the annotation, sequence ontology term. So in this case, this is telling me that I have an exon that start at this point and end at this point. Then I have 3 columns that tell me if I have a score, not in this case, if is sense or antisense, is sense in this case, And then the frame, in this case, I don't have frame because I have an exon. You will have frames with CDS. And then the last line that is going to tell me some things about the annotation. There are some lines like genes or mRNA that contains annotations too. So kinases probably will be a word here. So the command that I propose to use is, first you want to ignore all the comments for this file. Okay, so if I do this, I want to ignore all the comments. So I'm not going to have any comments. I'm typing this in head just to represent you what is the thing that you will take, okay, as a sample. Then I want to pipe this to kinases because I'm interested only when the word kinase appears. So if I do this, of course, I forget to put head, so it's going to print everything. So you see, it's marking me in red all the times that the word kinase appears. But I'm not interested in all these lines. I'm interested only in one column. And it's this column number 3, because I want to know how many of these things do I have. So if I say cut -3, it's going to cut only the third column. Okay, so this is my third column. My third column is full of genes and mRNAs. Then I want to count how many of the different elements do I have. And the formula to do that is the combination between sort and unique. So if I type this as sort and then with unique -c, first it's going to sort them by alphabetically, and then we'll count them. So if I do this, it's going to tell me that I didn't use a pipe here. Sorry. Now, okay. So the surprise, I have genes. For example, I have mRNAs, but then, according to this annotation, there is also 4 microRNA primary transcript that has the word kinase inside. I have 43 pseudogenes that has that word inside, 69 pseudogenic transcript that also have that word inside, and even 1 transposable element that has this word inside. Okay, so that is how I have been combining different inputs and outputs until I get some interesting solution. Okay, questions about this exercise? Okay, so if you don't have more, let me go to the last step. In the last step, we want to get the stats for each of the files. That, as I told you before, these are the files that you will be using to do your RNA-seq analysis from the experiment. And I want to get the stats for each of them. This exercise has different solutions, okay? One of them, the ones that require less knowledge is the one that require more work, okay? That will be just to run one by one this command. So if I go here, this is my directory. You should have something similar with this I2TA and the Illumina file. So one option is that I can do is I can run fastq stats. As you can see here, the name of the file. Okay, and then I want to pipe this in a file that is going to have. I'm going to change the termination of the file. I'm going to call this stats.txt. So if I do this, I need to wait. The program is running now. It's calculating all the stats for this file. Okay, and of course, because I'm using this greater than, I'm redirecting the output of this command into a new file that is called stats.txt.
Ari, I don't know if everyone has the raw or the FASTQ files.
Everyone should have the FASTQ files from the previous exercise. When I said something like, let me see, maybe I'm wrong, but in the previous exercise, organizing directories, exercise 5, see. Yeah.
Number 6. Yeah, I see it now. Yeah.
The number 6 is the part of the exercise where you should just have copied all the files there.
Okay, thank you.
Yeah. So the program is done. So if I go here, I can just take a look of what is inside, and you will see this is the output. No, so it's telling me that I have around 25.6 millions of reads. Okay, so that is the amount of reads, and then I have all these different options. So it's telling me also important that the length of the reads is around 90. Okay, yeah, so this is kind of the summary. If I need to run this command for all of them, I have several options. The first option is, remember that I can use the arrows, okay, and I can move reverse and forward in my history. So one option will be to just move to the previous command, going here, change what is new for the new file, and run the command again. You have 24 files, so it means that you need to do this 24 times, okay? But you only need to change 2 characters. You don't need to write everything. So that will be one solution. Other solution will be, so that is the other solution that I can think about it, without knowing much about coding, okay? Of course, one option will be just to write a command and a script to do this, okay? And a script just to do this and execute the script. But of course, that may take time, okay? But I still, I can, so, okay. So that is done. So you will see, okay. So as I said, you can repeat the command 24 times and then you will be done. Other option is to write a script. So to write a script, and as I said, teaching you to do scripting is out of the scope of this class. Still, I can give you some very, very basic insights. So a script is a text file that contains some instructions. So I can type nano, and then let's call this my script. Let me copy this file first. So if I write nano space my script, I will open a screen. This is a text editor, and then I can write here wherever I want. So the first thing that I will need is a script interpreter at the beginning of everything. So that will be being bash. First line always is pound exclamation mark root bin / bash. That is going to tell the system that this needs to be interpreted using bash. And then you can write the commands that you want to execute it. So one option, of course, is to write this command, and you can write this, you can copy and paste as many times as you want. So you can just do this. And then potentially you can go back and start to modify these files as you prefer. So you can say, well, this is not only 1, but this is going to be 2, and so on. Okay. Potentially, this could be faster than the previous option because at the end is copy and paste, no? So it still can be faster. For nano, by the way, when you want to go out, you need to type Control-O. Okay, so this cap is telling you what are the options that you have. So when you have this cap, it's saying Control, and then to write a file is Control-O. So I type Control-O. It's asking me file name to write my script. I push Enter, yes, and then Control exits, and I'm out of this. And again, if I run nano again, I can enter here. So that will be the solution 2. Solution 3 is if in some ways we can write a script to do this for us manually. And of course, again, the level of complexity here, it depends a lot. Yeah, so in your case, Nikolai, the thing that you get is the sum of everything. So if you are using the star, it's like when you are moving things. So the thing that is doing FastQ at that time, I think, that is running with everything, with all the files at the same time. So it's not going to give you one of these files per file that as you want. It will give you for everything. And we want to have one of these stats files per file, because if one of the sequencing, one of the samples fail, we want to really know which one was the one that failed, no? Because as I mentioned before, in the design, we need to have at least 20 millions of reads per file, no? To know that everything is working. So yeah, so that is why we want to do one by one. So potentially, one option that I can give you is kind of a recipe that I use. And this recipe that I use, in some ways, is kind of complicated. But let me tell you, let me show you if you like it, okay? So I type ls. If I type ls, I'm listing all the different files. I'm interested only in the files that are GC. So I'm going to type ls to something that say GC. If I do this, I have only the file that say GC. Now, potentially I could write something, okay, to if I can have the option to write things using this input with the command, that will be the only thing that I need. So I can write something like awk, that is this command that I need to write variables, single quotes, curly brackets, and inside curly brackets I can print, I use print and whatever I want. So for example, I can print hello, hello, and it's going to print hello, hello as many times as lines is reading from the previous command. But of course, I'm not interested in hello, hello. I'm interested in trying to get the information that I supply. So to get the information, I use the default variable $1. If I do this, you will see I'm printing hello, hello, and the name of the file. Of course, I'm not interested in hello, hello. So I can just delete hello, hello, and instead that write FastQ stats. So if I do this, I will be able to print FastQ stats. This is not a script itself. It still is something that you are printing in the screen. And this is not ended. So one option that I have here is, again, with double quotes, because double quotes means with print literally that, use greater than, and then $1, and then let's put a prefix that is going to be .stats. .stats.txt. If I do this, as you can see, I'm printing all these lines. People can be very insistent. Let me, sorry, this is person later. Okay. So, as I said, this is something that is printing in the screen. Once you do that, one option is I don't want to print this into the screen. I want to print this into a file that I can use as a script. So I can call this my script. Okay, so I'm going to redirect this to my script file. And then I have all this information there. Now I go, I do nano, my script. I have all this information here. I only need to add the interpreter. I write, I exit, and I already have my script. Now to execute my script, you'll need to change the permissions. So that is one option, or you can just write bash my script, and that will work too. Even that work even without the interpreter. So if I do this, it's telling me that FastQStats is a command that is not found because I forget. No, it's not FastQStats, but I forget this. So let me go back. That is a quick fix. So instead stat is stats. Okay, I'm going back to my script. Yeah, I did one mistake that now the problem is that I'm printing all the outputs. So let me fix this one moment. Because of course I was creating all these errors with the stats, so I want to remove those. So I type rm start, that means anything, and then I want to remove everything that is stats.txt. Okay, I have removed all these wrong files. Let's do these things about my script again. And now nano, okay, this looks fine too. Perfect. I already have the script, and now let's execute the script. Okay, so now I will be running the script, and this will be done automatically. Of course, these parts can be refined a little bit more, okay, but that would be a good way to do everything, no? So I'm using ls to retrieve the information of the file name. I'm redirecting all this information into a file, and then I'm executing the file. In your case, you have three options. You want to keep simple, write the command once and then move down, up, and down, okay? Just up and down and change the file name, okay? That would be one. Other option is copy and paste in a file and then execute the file. And the third option that you can see, this is one. Of course, there are much more refined ways to do. So you know a little bit about loops, as Tommaso is writing here. You know a little bit about how the bash loops works. You can use a loop to interact with each of the files and run the command for you. Of course, that will be another solution. Indeed, the solution that Tommaso is proposing is a more elegant solution. But of course, I don't want to explain you about loops and all these things about programming, okay? I will give you three options. You can choose whatever you want and you prefer in your case, okay? I can read the screen. Could you write here? Oh, yes, sure, of course. Useful guide for awk. Yes, I will. Yeah, I will send you an email with that. So this is the pipe. Yeah, I will send you that, and also for all of you that you are more interested about the scripting, I can upload a presentation about the scripting that I was using for my class in genomics. Okay, so you still want to learn a little bit more about scripting, you can take a look at the presentation. But of course, as I said, you cannot teach everything for a RNASeq course, no? So at least the minimum things in order to run these things. Questions that you may have about this part? Okay, so you don't have more questions about this part. the last thing that I'm going to do, because we are almost hitting 7, I really appreciate that you have all this resistance because this is a long class. So I'm going to give you the insights of the next exercise. So you will have these during these 2 days time to resolve it, and we will resolve this exercise at the beginning of next day. Next day also we will start to look for read mapping. Okay, so we will start on that part 2. At the end of the class, I give this kind of consulting time that still is a flexible time for us. So if for some time we are not meeting the schedule that I proposed to you, we always can push that. And as I said, I don't have any more exams, so I'm 100% due for your class for the next 2 days, okay? So as I said, so let me go back here to the last proposition for the class, okay? So this is introduction. So this is going to be SeqManipulation02 Practice. Just 2 exercises for this one. I want to remove the adapters and cleaning the low quality nucleotides, and also I want for you to evaluate the quality. So only 2 exercises, but because you need to do it with all these files, it will take some time. So the goal is using FastQMCF command, remove the adapters and the low quality nucleotides for the FastQ files, as I just explained in your presentation. If the read has a length smaller than 50 base pairs, also remove the whole pair. For that, you use the option -L50. The output should be gzip2. So to do that, it means that you need to put this gc in the output. You need to use this with all these files, and the recommended command is this one, FastQMCF -Q30-L50, the first output, the second output, adapters, FASTA, and then the first file, the first pair of the file. So R1 means the first pair, and then R2 means the second pair. Okay, remember that you have parents, so you have one pair and another pair. Okay, so you want to process the both pairs at the same time. Again, you can resolve this exercise just writing the command and repeating once and again and again and again. Or, yeah, so that would be one of them. The other is you want to get the stats, so you will run FastQC file, the FastQC command on each of the files. So that will be the second exercise. With the raw files, and also with the process files, so with the files that you are working today. And then tomorrow, well, in the exercise 1, you will produce some output, so you will need to run this FastQC with that output too. Last thing. So you see that now the program is running, but if I want to go out of the computer or the server, the process will stop. Okay, so if I close the window now, if I kick out of the server, the process will stop. And I don't want to have the computer connected to the server the whole time and run the exercise. So to fix that problem, you can use a special program that is called a screen. Okay, so let me stop this. So how do you run something with the screen? So you use your command. So in this case, you type the screen space -L, okay? And you run the command that you want to run, just adding before the command a screen space -L space, okay? If you do that and I click this, you see it opens a new window, or it opens kind of a new screen. And now the program is running. The key here is to go out of this screen. So to go out of this screen, you need to type Ctrl-A and D. And you see, I have been going out of this screen. It says detach it. But if I type the processes, you can see that I'm running these FastQ stats. Okay, so the FastQ stats is running in this screen that I create, this virtual environment that is a screen. Remember to go out. Okay, you type Ctrl plus A plus D. If I want to go back again to the thing that I'm running with the screen, I type screen again, but instead dash uppercase L, I'm using dash uppercase R, because uppercase R means retouch or reattach. In my case, it's giving me the message that I'm running two processes, not one, because I was using the server to run a different process. So I'm going to go for the last one, just the one that's starting. By the way, the time in the server is not the right, okay? It's 2 hours delay. So it's this 54922. So I changed uppercase R for lowercase r, this number, and then boom, I recover this. Okay. Remember to go out, Control D. To go in again, screen space dash R and the name of the number of the process. If I want to stop it, Control C. If I want to rerun this again, remember, Control screen space dash L space. Okay. Okay. So now you have the tools to run this. I think that's for today's enough. I think that there's a lot of information already. As I said, I want to thank your passion. So I will see you on Thursday at 9 a.m. again. Questions that you may have. So let me be stopping this, and then I will send you an email to every one of you. So I need to download all the recordings, and I will send you an email. Okay. Well, as I said, if you want the recording, just let me know, and I will send you the email with the recording. Otherwise, I will not send you because it's a lot of info, it's heavy, no? Okay. No, this is stop. Questions that you may have.